Join us as we DIY our 2400 watt inverter, a second 1000 watt inverter, and wiring the electrical system. Comment any of your electrical questions below. Welcome to Bussing on a Budget. I'm screwing in the solar wires here, and then next I'll attach the AC wires to the 2400 watt inverter. Part 1 of the electrical system is done. We've got the giant MPP 2400 watt inverter, ginormous battery lugs, strain relief, got solar on that side, we got the AC output on that side. Next up on the list, we are going to start connecting and mounting the main bus bars. Figure out where they're gonna go. Some thread locker on it. Call it good. We can close this. There we go. That's what we want. Much safer. Alrighty. So that will be main inverter lugs. Next up, we need to run the inverter plugs. These ones are massive. I think we might save these two for battery lugs. To put this right there, back there. All right, things are coming along. We have the bus bars installed and partially wired. So what we're looking at is 2000 watt inverter, 1000 watt inverter, 1000 watt inverter, 2000 watt inverter. They're all wired nice and snug. And then next to that we have the 120 AC box. Two of those. Probably not necessary, and it's probably pretty ridiculous to have two separate AC lines, but we're doing it. So this is Editor Daniel here. The reason we went with a 2400 watt and a 1000 watt inverter primarily was power savings. Running a 2400 watt inverter constantly, because we have an AC powered fridge, would pull about 50 watts continuous. That inverter is massive, and even on power saving mode, it still pulls about 20 watts. So I switched over to our 1000 watt inverter, which continuously only pulls about 12 watts, and in power saving mode only pulls about 2. So it saves a lot of power to have a smaller inverter. It is more inconvenient to have two wires, but that's why we did it. This is our 1000 watt inverter box. I'm stripping back the wire sheathing. We used 12 American wire gauge wire. This is underground speaker burial wire. It's rated for 25 amps. The circuit breakers that we're using are 20 amps. Our inverter is 2400 watts, which pulls also 20 amps. So when our inverter is maxed, the wires will be fully safe. And if there's a large surge load for whatever reason, the breakers will pop. Here I had to tighten the wire down a second time because the wire squished a little bit. I would recommend using those copper ferrules. I'm installing the negative to the negative block. Instead of using a ground block, I opted just for the negative. These zip ties are extra strain relief. The idea is that if it gets yanked, the wire can't easily come out of the box. These are also under our couch, so I don't really expect them to, but nice to be safe. This little wire connects to our positive bus bar. So there you have it. We have our live and neutral wires connected with our 20 amp circuit breaker. Can't say it's the most professional job, but this one works for us. Next up, we do this 4 more times. There we have it, our 110 volt, 1000 watt power distribution block. That took a little while. I think it turned out pretty well. The way this works, we've got 2 plugs on this side for the bedside, and the other one is for the kitchen side. So we're gonna have a plug that runs to the sink, so that we can plug in the stove or the coffee maker, the coffee grinder, all that stuff can just be run off the inverter. And then on this side, we've got our refrigerator. Right above it is the AC input, and that one connects to the bus bar itself. We've got 1 black wire going from the circuit breaker to the thing. It's a positive wire, but it just happens to be black. And we're gonna plug that box right in there, and then it'll connect to our inverter. Do a wire and plug head onto this. If you're wondering why is there no ground, we're actually doing an ungrounded 120 system, pretty similar to your 1970s houses. The only difference is we're using GFCI plugs. So instead of having a GFCI circuit with your circuit breaker, and then having GFCI circuit breakers and running the ground to the box and all that stuff, you can just use plugs that have a built-in GFCI, and then that protects you from shock. So it's easier and pretty much just as effective. The only downside is potential surge, aka like a lightning bolt or something. Whew! That definitely took a little bit of work, but we got her done, got her installed, got everything wired. That is our 120 1000 watt junction box. Nice wires running out the sides, nothing exposed, super duper secure. Open the little breaker window. And that is how you do a 1000 watt inverter. Next up, we gotta do the same thing for 2400 watts. So this is the other box. It's gonna go right here. The plan though is to do something like that.
If you're still with us, thank you so much for watching. Next week, we'll be tackling our 600 amp hour DIY lithium battery pack. If you haven't already subscribed, please consider. It's free and it supports our channel. Thank you and have a great one.